If you've ever seen a powder-actuated fastening system in use, you know how it can make your work easier by helping you do your job faster and without fatigue. Those systems are simple to use, but there are precautions and safeguards that must be observed. Before you can enjoy the benefits of powder-actuated fastening systems, you will need special training to learn to operate them safely and become a qualified operator. This presentation will not give you that training. What we're going to do here is show you some of the basics to make your training and qualification easier. We'll be talking about the various materials you'll be fastening into, the different types of fasteners you're likely to be using, and the power load that makes the whole thing work. We'll also tell you something about the tool itself and how to operate it safely. You might be wondering just how safe these tools really are. If the tools are used improperly, accidents can happen. Powder-actuated tools are designed to be operated safely, but they can't do your thinking for you. Let's take the elements of a powder-actuated fastening system one at a time. We'll start with what we call the base material, the material that holds the fastener in place. We start with the base material because the first thing you need to know about a job is what is being fastened to what. Are you fastening wood to concrete, wood to steel, sheet metal to solid masonry block, steel to steel? Then you need to know if the installation is going to be temporary or permanent. Those answers help determine the choice of the fastener, the power load, and sometimes even the particular tool to be used. In general, base materials such as steel, concrete, and masonry are suitable for powder-actuated fastening. However, some materials are too brittle, too hard, or too soft to be fastened into. Here's an example of what can happen when the material is too brittle. Materials like brick, glazed tile, slate, and glass could crack or shatter on impact, and the fastener could deflect or pass completely through and cause injuries. Material that's too hard can't be used as base material either. The fastener won't be able to penetrate and could easily deflect or break. Marble, natural rock, and spring steel are all examples of materials that are too hard. And even in suitable steel material, a welded area is too hard to be fastened into. Soft materials like wood, plaster, drywall, and composition board can't hold the fastener, so they're not suitable for use as a base material. If the material is too soft, the fastener could pass completely through and become a dangerous flying object. Before you start to make fastenings in an area, put up a warning sign and make sure you check the other side of the wall. If other people are there, clear them out of the area. Before you start, put on goggles. You need to know exactly what kind of material you're working with, so you can make a fastening that will hold the way it should, and also to keep the work area safe for you and your fellow workers. There's a simple test you can make to find out if material is suitable for fastening. It's called the center punch test. With an ordinary hammer, use a fastener as a punch on the material you're checking. Do the test on a part of the material that won't show later. If the material shows a clear impression from the fastener point and the point is not blunted, the material is all right to use as a base. But if the point is blunted, the material is too hard. If the material cracks or shatters, the material is too brittle. And if the fastener sinks into the material with an average hammer blow, the material is too soft. By the way, all materials must be tested for suitability. That means both the material being fastened and the material you're fastening it to. Be sure to test each of them separately. The fasteners used in powder-actuated tools are made of special steel and heat-treated for the extra hardness and toughness they need to penetrate concrete, masonry materials, or steel without breaking. The two basic types of fasteners are the drive pin and the threaded stud. These are examples of drive pins. A drive pin looks like a nail, and it is designed to attach one material to another permanently. Wood to concrete or steel, for example. Threaded studs have a shank portion which is driven into the base material and a threaded portion to which something can be attached with a nut. The use of the nut to hold the work in place allows it to be removed or replaced at any time. There are several fasteners which have special uses. The eye pin, for example, has a hole through which wire or chain can be passed for hanging such things as suspended ceilings or light fixtures. Other special fasteners are combinations of fasteners and accessories, such as the pre-assembled ceiling clip on the left and the pre-assembled conduit clip on the right. Now that you know something about base materials and fasteners, let's talk about what drives the fastener into the base material, the power load. The power load is a powder charge and comes in a lot of different sizes, shapes, and calibers. Different jobs need different amounts of force to drive the fastener, so power loads are available in 12 levels or strengths. The lightest is the number 1 load, and the heaviest is number 12. There is a standard number, color code, and case color to identify the level of all power loads. Let's take a look at that code now. There are 6 basic colors used: gray, brown, green, yellow, red, and purple. Each of these 6 colors is used twice in identifying the 12 power load levels. The cases for load levels 1 to 6 are brass colored, and the cases for levels 7 to 12 are nickel colored. How do you know which power load to use for a particular job? Each tool has a range of acceptable loads which is recommended by the manufacturer. To get the exact power level you need for a given job, find an area in the base material where it won't matter and make a test fastening. Always start with the lightest power level recommended for the tool you are using. Increase the power level by single steps until the right penetration is achieved. Remember, it's important to use power loads properly according to the tool manufacturer's recommendations. There are 2 types of powder-actuated tools: direct acting and indirect acting. But the general procedures for operating the tools properly and safely are similar, no matter what the type. Let's talk about some of those procedures and safety guidelines now. Much of the fastening you'll be doing will be into concrete and masonry materials. The suitable types include poured in place, precast and pre-stressed concrete, solid concrete block, and horizontal mortar joints. You need enough material around the fastener to get a good grip, so it's a good idea not to fasten closer than 3 inches from the edge of the masonry or concrete. If the material cracks, the fastener won't hold, and a chunk of the material or the fastener could fly away and strike you or a fellow worker. Setting the fasteners too close together can also cause masonry to crack. There are tables available to show you the right spacing, but keep in mind that the larger the diameter of the shank, the more space is needed in between. The concrete or masonry has to be thick enough too, at least 3 times as thick as the fastener penetrates, with a minimum thickness of 3 inches. In general, horizontal mortar joints are suitable for fastening, but vertical joints are not. The vertical joint is usually not solid mortar and won't provide enough compressive strength to hold. Spall is something you're almost sure to come across when you fasten into concrete. Spall is simply the breaking of the concrete on the surface around the fastener shank. Surface spall is more of an appearance problem than anything else, and it's not likely to reduce the holding power. But if an area is already spalled or cracked, or you know a previous fastener has failed there, never try to fasten into it. A fault in the concrete, like the one you see on the left, could cause the fastener to fishhook, as you see on the right, or to ricochet and possibly cause serious injury or death. Almost all the metal you'll be using as a base material will be structural steel. Be sure to check the hardness first by doing the center punch test we described earlier. Use goggles or safety glasses when doing the test. It's possible to make a good fastening if the steel is too thick for the point to penetrate completely, but for maximum holding power, the fastener has to penetrate completely through the steel. Be sure the thickness of the steel is greater than the diameter of the shank. You have to be careful about fastening too close to the edge with steel. The minimum distance from the edge is 1/2 inch, unless the manufacturer's instructions for the specific application tell you otherwise. The steel between the fastener and the edge can stretch so much it won't grip the shank. The steel might also break and the fastener fly off. This fastener has been overdriven, and that's something to avoid. Too much driving force can damage or break a fastener, reduce holding power, or damage the tool. When you're using a powder-actuated tool, there's always the chance of a misfire. If that happens, first, hold the tool in operating position for at least 30 seconds. Don't pull the tool away to look at it. Relieve the pressure on the tool, then try to operate the tool a second time while you hold it in position. If the tool misfires again, hold it in operating position for another 30 seconds. Then, if it still hasn't fired, carefully remove the power load and place it in a container of water. Don't throw it in a garbage or trash receptacle. Give it to your supervisor for disposal. The shield on a powder-actuated tool is used both for safety and for adapting the tool to the job. It not only protects against flying particles, it also helps hold the tool perpendicular to the work. Always be sure to use the proper shield, adapter, or accessory suited for the application as recommended and supplied by the manufacturer. You need more protection than the shield though, so always wear safety glasses, goggles, or a face shield whenever you operate a powder-actuated tool. Good hearing protection is important too, especially when you make fastenings in confined areas like small rooms, tanks, vaults, or ship compartments. A hard hat is recommended, and it might also be required where you work. It's important to remember that anyone helping you or working nearby must also wear personal protective equipment. There's only one time a powder-actuated tool should be loaded, and that's when you're actually ready to make a fastening. Always load the fastener first, then the power load. It should be pretty obvious that you never carry a loaded tool to and from a job. Never leave powder-actuated tools lying around. Store them unloaded in a locked container, and also store power loads in a locked container. Don't allow unauthorized people to handle either the tool or power loads. There are some things to watch out for when you carry the power loads to and from the job. Never carry power loads in pants pockets. You might overlook them when you leave the job site. Never carry more than one level of power load in an apron. Always check the color code on each power load before you insert the load into the chamber. And don't forget to check whether it's a brass or nickel-colored casing. Never force a power load into the tool's chamber. If you have to force it, something's wrong. Your powder-actuated tool is going to be as safe as you make it. And one of the best ways you can make it safe is by taking good care of it. Check any tool you're going to use before you start each day's work. If there's anything wrong with it, turn it in to be fixed. Whenever you're working with powder-actuated tools, keep in mind that there may be some danger to other people nearby. An improperly used tool can cause serious injury or death. Don't let bystanders gather around where the tool is in use. Flying material might be dislodged by the fastener, or the fastener could be deflected and ricochet. We've covered a lot of ground in this presentation, but the important things to remember are know your base material and always use the right fastener, the right power load, and the right tool for the job. Always observe these safety rules. Use the proper shields for your tool. Use personal protective equipment that's appropriate for the job you're doing. Only load your tool when you're ready to use it. Store your tool in a locked container. Never carry power loads in a pants pocket. Always check to be sure you have the right power loads. Check your tool before using. Keep others clear of your work area when you're using a powder-actuated tool. And remember, you're not a qualified operator yet. That will come when you successfully finish your actual training. Use that training, treat your equipment with respect, and that way powder-actuated tools can help you do your job quickly, efficiently, and safely.